Hey guys. One sec. Let me know if you guys can see my screen. Cool. So yeah, thank you guys. Thank you, HashKey, for inviting us. So I'm going to be talking about Sygma, essentially our interoperability protocol. I've got a couple of slides here just to give you a brief outline on what Sygma is. So essentially, Sygma is a modular security and transport layer that enables general message passing, interoperability, and seamless connection between EVM substrate and beyond. So I'll touch on a couple of points and double click on a couple of those topics within that overall vision. Now, thanks to ChainSafe's incubation at Sygma, we've been able to spend the last 12 months focusing on evolving ChainSafe's hugely successful EVM to EVM bridge, chain bridge, with a focus on interoperability. Now, most people understand interoperability as just token transfers or even cross-chain bridging. Whereas for Sygma, token transfers are just one use case. But blockchains, like much of the internet, it's essentially a mechanism to transfer and consume data. So this is particularly so with general message passing, which allows our Sygma protocol to pass arbitrary or general data between chains, and enable developer building on one chain to actually call functions on another connected chain. As you can see in the bottom right, we are currently in mainnet, and what Sygma allows us to do is actually add cross-chain functionality within apps with minimal effort. So just on top of that transfer use case, we can deposit from anywhere. We can bridge in-game assets or NFTs across chains, such as integration into and working with the ChainSafe gaming SDK, which Colin just took you through. We can bridge directly from native wallets such as Talisman or MetaMask, and we can actually integrate into any EVM or substrate-based dApp. So what I actually want to show you is a live demo, but all of Sygma's functionality is all wrapped into one SDK. And this SDK can actually be installed with essentially 2 command lines. I'll point you to the docs. It's very easy to get up and running, as well as actually send a cross-chain call between an EVM blockchain, as well as a substrate parachain, such as Polkadot. Cool. I'm just going to switch screens just to give you guys a live demo. Now, as I mentioned, we're currently in mainnet. So as you can see here on the right is our actual protocol explorer. This tracks essentially all the transactions through the Sygma protocol. We are increasing the number of EVMs available every 4 weeks. So just last week, we added Base. We also added Chronos as well, and we support both networks. As well as you can see here, the general message passing function, as well as actual fungible token transfers. So what I'm going to show you here is Subbridge. Subbridge is run by the Filer network. They are one of Polkadot's biggest parachains. They have fat contracts, which are smart contracts across substrate networks, as well as index, the substrate-based DEX. So Subbridge has essentially used the Sygma SDK, and as you can see here, it's powered by Sygma. We can natively bridge between Ethereum to either a Polkadot parachain, Kusama parachains, and as you can see here, Azstar. And we're also essentially rolling out, I'll touch on it, a trustless implementation of Sygma as well. And this will happen across the rest of Q4 and early into next year as well. So I'm just going to bridge 10 Filer tokens, which are Ethereum-based tokens, and they will essentially arrive in substrate Polkadot parachain. Hold on one sec. So you just need to approve, as you guys probably are aware of, and then actually transfer the bridging transaction. And it's a matter of seconds before it shows up on the Explorer. Once it's approved, I'll submit the transaction, and I'll just sign it on my end. Cool, and let's go through. I'm just going to refresh the mainnet Explorer. And as you can see, that was executed. No, that's not my transaction. One more set. Okay, so this is the pending transaction that just went through for 10 Filer. And that's essentially bridged from Ethereum to Filer's Polkadot parachain for 10 Filer and a bridging fee of 0.0001 ETH. So that's just a quick example of what we currently offer. And this is simply integrating the Sygma SDK into their front end. What we will be coming out in Q4 is also a widget that allows for bridge and a swap transaction all in one interaction. So I'm just going to jump quickly to some of what we're doing, our road to trustlessness. So our development roadmap actually focuses on two further phases. One is extending our relay network with trust minimized nodes. And these are based on blockhead Oracle technology. So we are actually introducing an optimistic implementation as well as a ZK proof validity implementation. And our phase two will actually then become essentially end-to-end trust verification. The whole point of Sygma is, as a lot of your previous presenters have talked about, abstracting away the complexity. Where we will be with Sygma once our trustless implementations are live on mainnet is the ability to actually customize and tailor your security. So you can actually choose your transport protocol, or you can have the system chosen for you. And that essentially balances between speed, cost, and security, depending on your context and depending on use cases, whether it's in-game assets or highly valuable NFTs. You can actually pick your speed, cost, and security. Obviously, if you want it more secure, it will cost more. It will be slower, but it'll be essentially trustless and highly secured as well. This is where Sygma will be, and that's our focus for 2024 and launching that into mainnet production. Cool, and that's just quickly. And essentially, you can go on our Twitter, Build with Sygma, or our website, buildwithsygma.com. Sorry, I did have the docs. I'll just give me one sec. I just want to get the docs up. Okay, I will stop sharing. But essentially, yeah, you can visit our website, buildwithsygma.com, for our docs as well as our blog that regularly produces essentially articles across what we're doing with our ZK implementation as well. Cool.